I'd like to at least get you, if you are interested, to put your name, and if you are associated with a school district or a company or organization, if you wouldn't mind putting that information into the chat, so we'll have a general idea about who actually showed up today. Thank you so much for taking time out of your lunchtime here to join us. So it looks like some people are still joining the Zoom meeting here. We'll wait a little longer, a minute or so, for some more people to join. They may be grabbing some food or drink, or trying to finish something up before they get on this call. Again, anyone on the Zoom, if you don't mind putting your name and the school district, if you're with a school or company or organization, put it into the chat. And as we go into the presentation and questions or comments pop into your head, go ahead and put those into the chat as well. We will be addressing those at the end to allow Jim to get through his presentation. You never know, your question may be answered in his presentation. So we will get to those questions at the end. Thank you very much. All right, 2 minutes and counting here. All right, looks like we've added some more people. Again, thank you everyone for joining us here today. Next time maybe we need some music or some kind of cartoon or something to entertain people in the meantime. All right, here we go. 3 minutes after. Hi, I am Molly Rook. I'm a member and volunteer with the North Texas Renewable Energy Group. Some of you know I'm also a member with lots of other great organizations working on climate and environmental solutions. I'm focusing now on the North Texas Renewable Energy Group because they hosted a wonderful in-person tour led by Jim Scrivner last January, right before the pandemic hit. And there were those of us who braved the minor snow flurries to get out there to the presentation. So this school that you'll be hearing about today was the focus of that net zero energy tour, and it is the Lady Bird Johnson Middle School in Irving ISD. But we wanted to further expand those who can learn about this great example of a net zero school, including Dallas ISD and others who have bond money and plans to build and renovate new schools. So Jim Scrivner has graciously accepted our request to talk about and answer questions about this net zero energy school. So I'll give you a little background for Jim. He's been employed with the Irving Independent School District since August of 2002. He began his career with Irving ISD as a technology education teacher at Travis Middle School and was a classroom teacher for 4 years. He served as vice principal at Sam Houston Middle School for 2 years, and in June 2008 moved into the position of energy manager. In March 2016, he was promoted to the position of Director of Facilities and Operations for Irving ISD and became the Executive Director of Facilities and Support Services in August 2016. Prior to his career in education, Jim spent 20 years in high-tech engineering, sales, and management. Jim received a Bachelor of Science degree in engineering technology from Texas A&M University in 1982 and a master's degree in educational administration from the University of North Texas in December 2007. His primary responsibilities include coordinating and managing the maintenance, grounds, and environmental quality, warehouse, custodial, energy management, construction, and facilities rental functions for Irving ISD. Jim is an accredited Texas Energy Manager through the Texas Energy Managers Association. He currently serves as treasurer for the state board of the Texas Energy Managers Association and treasurer for the board of directors of Keep Irving Beautiful. He's a busy guy. So without any further ado, I introduce Jim Scrivner, and take it away, Jim.
Thanks, Molly. I hope everybody's having a great day today. A lot of y'all have been over and have seen Lady Bird Johnson, but I never get tired of talking about it and the technologies that we have and involved with the school. For those of you that have been exposed to Lady Bird Johnson, we built Lady Bird Johnson and opened it in the fall of 2011. So guys, this fall will be the end of the 10th year for Lady Bird Johnson Middle School. I mean, time really flies when you're having fun, especially the last 12 to 18 months with the pandemic. But I just wanted to give everybody a good overview of Lady Bird Johnson Middle School and some of the technologies employed to reduce energy consumption, some of the technologies employed to produce energy, and then just some of the overall effects that we've seen over the years with Lady Bird and how we're going to move forward within Irving ISD, and also some of the changes we've seen in the industry. So with that, we'll get right into this. I've got about 24, 25 slides. I'll try to go through these fairly quickly, but I want to start with some relevant quotes that go all the way back into the early 1900s. When you really start thinking about energy and you think about solar energy, you think about the sun, and you think about what's going on, all the way back with Thomas Edison, I put my money on the sun and solar energy. That says so much. Albert Einstein talking about solving problems. Guys, that's what we do every day, is solve problems specifically for the future. We're, especially in education, Irving ISD, Dallas ISD, Arlington ISD, Frisco ISD, we're building future minds. We're setting the foundation for the future. And that's where the thoughts behind Lady Bird Johnson really came. We are obligated to leave the country looking as good, if not better, than when we found it. That was from Lady Bird Johnson back in 1968. This was the first net zero public school in the state of Texas 10 years ago. There's a bunch of them now. It was the first net zero middle school in the country. And as of me checking about 10 months ago, it was still the largest net zero public school in the country. There's a couple that are under construction that are larger, but they had not come online yet. Again, we named it for Lady Bird Johnson, because you think about what Lady Bird Johnson did when she was First Lady. And she started so many of the beautification projects in Texas. It was just a perfect fit to name the school, after Lady Bird Johnson. It was just, I mean, it really tied in together with her concepts and also the concepts we were trying to accomplish with the school. Well, let's talk about some design strategies and talk about the school a little bit. You know, even President Jimmy Carter got in there. And when we had the oil and gas crisis, and we must prepare quickly for a third change to strict conservation, the use of permanent renewable energy sources like solar power. You'll actually hear a lot of different people talking now about wind farms, solar panel farms. Those are becoming much more prevalent. We're also seeing a lot more involvement and also actual intelligence of our government from the federal, state, and local levels, where they're getting involved with renewable energy strategies and conservation strategies. And I think we're just going to see that increase significantly over the next 5 to 10 years. Well, let's talk about the strategies that we use on Lady Bird Johnson to reduce consumption. So the main thing you got to do is you've got to do energy reduction or resource reduction. So we do rainwater harvesting throughout the entire school. We've got a great big storage tank right back here that we dump all the rainwater in, and we then use that rainwater to water our flower beds and grass that are around the campus. So we don't have to use water from the city. We also harvest gray water from our sports areas, the athletic areas. So from the washer and dryer and the areas in here, we harvest that and put it into the tank also. Energy Star rated kitchen. This was back in 2011. We called this our kitchen of the future, but now nearly all of our kitchens in Irving ISD use the same philosophies that we employed at Lady Bird Johnson. We do a cook to serve methodology, not a cook to warm. Most school cafeterias you go into, they cook all the food beforehand, and it's either brought to the school or it's put in warmers and sits in warmers until the kids come and actually get it. Again, you're using a lot of energy keeping those warmers running. And also, you're also not serving as fresh a food as you should. With the cook to serve mentality, you're saving energy and providing a much fresher lunch for our kids. All of our laptops and all of our wireless connections, we're totally wireless on this campus. We saved over $100,000 in copper alone by going to a totally wireless infrastructure for computers. There's only one hard port in each classroom, and that is for the voice over IP phone and for emergencies. And then holistic monitoring of energy use. What I mean by that, ladies and gentlemen, is we can actually monitor down to an individual classroom level and see what the energy consumption is in that actual room. When we first started this project, we actually had a group of 8th graders in their science classes that were monitoring all the different rooms. In fact, they were monitoring the restrooms. We have the Dyson hand dryers in there. The hand dryers, you stick your hands in there and they use an air curtain to blow the air off your hands. My students were saying, look, we're using too much energy. Every time those hand dryers come on, they're consuming way too much electricity. So the teacher and I got together and we came up with the project, said, okay, let's do an analysis of the energy consumption of the Dyson hand dryers versus the cost of paper towels, the cost to dispose of paper towels, the long-term effect of having to dispose of paper towels. But let's also remember with paper towels, they're sometimes put down toilets and put down your sinks. So let's add some plumbing costs in there for plumbers to come out and fix that. And that's also put in there at least twice a year. Paper towels are caught on fire in a middle school. So let's do the cost of, response by the fire department. So these 8th graders went out and did that analysis, and they came back and said, Mr. Scrivner, you're right. The Dyson hand dryers are a much better solution than the overall cost of doing paper. So obviously your energy model is wrong and you need to fix it. So that was really fun. The kids literally, they help us maintain and model our own school. Something that every campus, guys, should have anymore, and anything we do when we do upgrades to our campuses, is we work on building envelope. What I mean by building envelope is the transition from the inside of the building to the outside of the building. If you can increase efficiency there, you reduce the heat moving in and out of your building. It's basically making the building more efficient. You see this a lot in all your new schools, and you see in nearly all of your new buildings. But we actually increased wall insulation. The insulation at Lady Bird Johnson's 2 inches thicker than our normal buildings and our other buildings. Also more insulation in the floor and in the ceiling. We use higher efficiency thermal pane glass. It's got inert, I believe it's argon that's actually inside the glass, so we get less transmission of heat. We do solar shading, so in the summer, when the sun's at a little bit higher angle, the sun actually does not come in the windows and transfer heat into the actual spaces themselves. However, during the winter, since your sun's actually lower, we do get some heat transfer and some light coming into the actual classrooms themselves. We also had, every one of our classrooms has windows in the classroom so that we can have daylight in the classrooms. We also do light harvesting. We have sensors in our lights. So our sensors can actually sense the light coming into the room, and we'll start turning off multiple light fixtures to make sure we maintain a good light level, but where we don't need it, it automatically turns that off. Very good systems that work well. And then of course we have, solar panels on the roof, which we actually trap the solar energy, but that also gives us another layer of insulation between the actual roof material itself and the solar panels, so we get less direct sunlight impingement directly on the roof, we could transfer into the building. Geothermal technology. I know most of the people have heard of geothermal technology. Excellent technology for HVAC. We use this exclusively at Lady Bird Johnson Middle School. We use a ground loop water transfer heat system. I'm pulling a blank on exactly how many wells we put down over there, but there's a lot of them. But what this actually allows us to do is during the summer, we take the heat out of the building, transfer it via water, and put it into the ground, into the wells itself, into the ground surrounding the wells. In the winter, we take that heat back out and bring it back into the building. Again, a very, very efficient method of heating and cooling. Your air conditioning at home normally does heat transfer into the air. Your big unit on the outside, it's taking the heat from outside your building, put it there, and then transferring it into the air. That works, but it's nowhere near as efficient as storing that energy in the earth and using it later. Again, this is a very, very good system that I would recommend for anybody. If you're doing a full, complete HVAC rework at your house, you might want to consider looking at geothermal technology. It's just so much more efficient. It uses about half the energy of a traditional HVAC system. So we talked about strategies to produce energy. We need to push ourselves to make as many reductions as possible in our own energy use first, and that takes time. We must do this quickly. The climate will not wait for us. We keep hearing more and more about climate change, greenhouse gases, et cetera. So guys, you're going to see more in regulations requiring us to do these kind of things. At Lady Bird Johnson, we originally used a Solyndra system. Solyndra Power was the most efficient photovoltaic system that was available at the time back in 2010, 2011. When we actually opened this, it was the tubular system. So you get the direct energy hitting the tube, then reflected energy also coming off the white roof in there. Solyndra went out of business in into 2012 during one of the crashes of the industry. But we still have a lot of the Solyndra panels. Originally, we had approximately 66,000 square feet of solar panels with about a 550 kilowatt solar array. Everything we had at one point in time on top of Lady Bird Johnson was a Solyndra array. There's basically the layout of the array on the roof. Again, there's approximately 66,000 square feet of solar panels. And that generated about a 550 kilowatt array. We also have a viewing platform for student access right here where you can actually see what the Solyndra panels look like. That's great for tours and things like that because a lot of people have never seen a commercial photovoltaic system in operation. And that actually gives them an idea of what these actually look like. The other thing we did with solar/daylight is these are actually dormers all the way down the center hallway. They actually have a very large northward facing window, and then they angle down and attach to the roof. What this allows us to do is harvest the daylight that's coming in from the north without the strength of the very, very strong southern sunlight that we get in the summers. So we get the daylight, we don't get the heat in there. Another use for these, this whole area right here is a very tall 2-story environment. These also serve as heat sinks, as basically as heat traps. So as people are moving around inside the building, any heat that we do have in that big hallway tends to get pulled up and can get trapped up in those actual areas, the daylight dormers. After 2012, again, everybody remembers the hailstorm of 2012. Guys, we had hailstones this big at Lady Bird Johnson, and I only lived about 10 blocks away from it, and one went through the back of my wife's car. It was literally larger than the biggest grapefruit I've ever seen. So on the west, what we did then is we took the undamaged Solyndra panels, put those all on the east side of the building, and went with the Kiosk panels on the west side of the building. So we now have 910 Kiosk panels up there, and it's a 292 kilowatt solar array. So in just basically about 2.5 years between the time we bought the Solyndra panels to the time we bought the Kiosk panels, their efficiency had gone up about 18%. And it's continued for the last 10 years. The new solar panels are probably 40 to 50% more efficient than my Kiosk are right now. So what you see now is in the green is 910 Kiosk panels, and in the blue you see 1,511 of the original Solyndra panels that are up there on the roof. Conclusions you can see that we've seen and we've discovered over the last 10 years of working with this. Guys, solar works. What's great about solar is when you've got a good, bright, sunshiny day and are generating, a lot of electricity, that normally happens when electricity costs the most. July, August timeframes. It really helps in a school situation because that's when I typically use my buildings the least, is in July and August. So we actually go in there and make up some of the additional energy. One thing that would help solar so much is a better storage technology. One of the reasons we did not take Lady Bird Johnson off grid is we could not afford enough batteries, literally enough battery technology to basically keep the building running when the solar panels were not working. If once you see a better battery technology, that's the key right there. Once you get that, then solar power can take over the entire industry. It can completely replace fossil fuels. Your costs are coming down. I mentioned earlier that, we've seen significant decreases in the cost and multiple increases in the efficiency of the actual solar panels. When we built Lady Bird Johnson, just the solar array cost us about $5 a watt. That was 10 years ago. Last year when I was doing some analysis, I found some large commercial arrays in the 40 to 60 to 80,000 square foot range that were actually lower than $2 a watt for the actual solar array itself. So we don't know what's going to happen. Again, as more and more of the solar panels are being built, as more and more competition goes on, as more and more drive goes on to do these green jobs, I think you're going to see a significant decrease in the price per watt of the actual solar panel. So it just gets better. It just gets more efficient and better to do every day. Everybody always likes to talk about my wind turbines at Lady Bird Johnson. Guys, honestly, they're there for the educational program. They're really not there for energy generation. You've really got to go out into West Texas, North Texas, someplace where the wind profile is much better than it is in Irving, Texas. And also you've got to get out into a rural area in an urban area. We actually put 12 of the SkyStream 3.7s in here. I believe it ran about $150,000. But again, they're there for educational purposes. They don't generate a whole lot of industry. I think I get about 6,500 watts out of them a year, or kilowatts out of them per year. But again, they're there for the educational component, the educational concept. Because again, they don't work very well in an urban environment, but you get outside of Dallas-Fort Worth area, you see a lot of wind power out there. Great thing about wind blows 24 hours a day. You're not as limited. But again, for actually in a school, you use it as part of the educational component, not for your actual energy component. Here's the actual data on what it cost us to build Lady Bird Johnson Middle School. It's a little over 152,000 square feet. And again, we did this 10 years ago, but you can see down at the bottom, all of the net zero features that we talked about ran about $3.75 million, $3.6 million additional cost, or about $25 a square foot. But that does include $143,000 for your your wind turbines, $277,000 for a water well. We drilled an over 2,000 foot deep water well to do to water all of our athletic fields. Native landscaping, a very, very extensive energy monitoring system. So you can see a lot of things we put into this, but they're all things that have a fairly good and short payback. One of the problems we have right now for anybody in the industry is just the cost and availability of materials because of the pandemic. If you're trying to build something right now, it's very difficult to even get materials. And I've seen costs increase 4, sometimes 5 times on things as simple as plywood. So, we're going to have to see how things really shake out over the next, over the next 12 months or so, as far as, building costs and building materials. But again, this is a very good representative example of what it actually costs to do this. And again, it wasn't that much more cost to do these level of features. What I've got here is this is an analysis that we did, a payback analysis on looking at just a solar only building, a net zero building in the red, just a base, in the purple, a base 4-pipe chiller system. And then in the blue up here, a base geothermal system. So you can see that the geothermal system is much more efficient than a 4-pipe central plant system. If we did solar only, you see that it does start paying back. It's got an opposite curve of your regular HVAC, but you're way out there 20, 25 years before you're actually paid for just for the system. Again, these days, guys, geothermal does not cost much more than traditional HVAC. There's not that much of a difference in the actual cost, which makes that much easier to tolerate. The one I really like, though, is the red line. That red line there shows a 12-year payback by going with the full net zero package. And what I mean by that is the rainwater harvesting, so we reduce our water consumption, the building envelope improvements, the geothermal inside, the photovoltaic, all that brought together, the upgrades and efficiencies in the kitchen, daylight harvesting in the classrooms, all those concepts brought together basically had a 12-year analyzed payback on a building we expect to last 50 to 70 years. So that's pretty impressive. And I'm going to tell you one other thing. I got a rebate check back from Encore for over $800,000, which pushed this line crossing from 12 years right here to a little over 9 years. I just hit my payback point about 5 months ago on this. So we've already paid for these upgrades in less than 10 years due to the rebates and things like that. But they're going to continue to pay us. These efficiencies are going to continue to pay us for the life of this building. This slide basically talks about energy use index. That's a number you can use to see how efficient a building actually is overall. We calculated that Lady Bird Johnson was going to be about a 22.8. The lower the number it is, the better. Our first 4 years of actual production, we ran about 19.97. Lorenzo de Zavala is basically the same footprint as Lady Bird Johnson with traditional systems in it and not the upgraded building envelope, et cetera. It's a 59. Average middle school in Texas runs about a 52. I wanted to show you something here, though. In blue is Lady Bird Johnson's actual energy cost comparison versus red is de Zavala. When we first opened the school, the actual blue from Lady Bird was much lower than de Zavala. It was way less than half. It was about a third of de Zavala. But guys, what I needed to do for the district and for my stakeholders and for the taxpayer state of Texas is we proved the net zero concept. This is my most efficient building in the district. Starting in about 2014, 2015, we started using this building more and more and more often. And in fact, in the last 2 years, we probably used this building twice as much for after-hour activities as we do at some of our other middle schools, specifically de Zavala, because it's one of my least efficient schools. So what you'll see is it follows the same curve, but the difference between Lady Bird Johnson Middle School and the de Zavala, the de Zavala Middle School has gotten smaller. But again, that's a lot due to the change in our use profile of the actual school. But again, you can still see it as significant, tens of thousands of dollars every year less to run Lady Bird, even though we're using it more. We talked about, other actual physical strategies, guys. Actually some operational strategies. We monitor HVAC control and monitoring. HVAC systems are scheduled in zones. If we're doing something just in the athletic area, that's all we run. But we do that in all of our schools in Irving ISD. At this particular school, room temperatures are set at 74 degrees for cooling and 70 degrees for heating. Very nominal. If you read a lot of educational work in there, says that the optimum learning environment is between 72 and 76 degrees for your middle school kids. So we try to stay right in that area. We talked earlier about the digital lighting modules for lighting and plug load control. Guys, we can see down to an individual classroom. If somebody goes in there and plugs a coffee maker in, I can see it. I can see that thing's plugged in there, and we can walk in there and explain to the teacher, no, we don't want to do that. Grid point energy manager to monitor our solar PV production and total building usage. And then we actually have sub-meters that are spread out throughout the building that serve as a backup, so we make sure that the monitoring systems we're using, that we actually have the raw data off of electrical meters and sub-meters so that we can verify everything that we're doing. Other cost-saving measures, we have a paper recycling program. We talked about the water well for the athletic fields, gray water and rainwater harvesting. Yeah, the city of Irving, when we first started this up the first year, they came out and wanted to know why we weren't using any water. It's a middle school. Our use of water in this middle school is about 10% of what it is on our other campuses. We use a low maintenance flooring. It's a rubberized flooring. The other thing we're looking at now is LVT, luxury vinyl tile, is the actual product that we're starting to implement and put into our schools. It doesn't require stripping and waxing like your old VCT. It's just a very, very tough floor. We don't have blinds or window treatments, which reduces our cleaning effort. We didn't allow personal appliances, which means a teacher can't bring a refrigerator or coffee pot and actually have it in their room in this building. And we actually have a policy that goes out throughout the entire district that an individual teacher can only bring in a coffee pot or a microwave. So what they'll do is they'll team up. The next door teachers will team up. One will have a coffee pot and one will have the microwave. But again, we do that for two reasons. One, it saves a lot of energy. And number two, again, I said my buildings are 48, 49 years old, and some of them I've got some pretty old infrastructure. And if you have a coffee pot going off at the same time as a microwave on a single circuit, sometimes you can pop breakers and there can be some damage associated with the older infrastructure. And then we limited the numbers of copiers and printers. For a long time, the general philosophy was every classroom gets a printer. Well, the whole district is going away from that philosophy. And in fact, education in general is going away from that philosophy. We don't want to print out a worksheet and give it to the kids and have them work on a worksheet. We want to do interactive problem-solving activities. So you're seeing the printers going away naturally because we're changing how we teach. So that's, a good quick, 30-minute overview of my 10-year-old school.
Thank you very much. That was great. We have some questions in the chat here. It looks like, I think you've answered this one pretty much. Have you calculated the payback of the different measures implemented, solar panels, geothermal, structural measures, as compared to business as usual built school? I don't know if you want to comment any further on that, or how you had that broken down into specifics of which things produce which savings.
Yeah, I've got that data, but the main thing we looked at is I looked at the total package when we did the initial analysis, and we did the total package again, because that's just kind of what we were looking for. How did it all come together? How does it work as a package or as a team of all the different things? And again, our initial calculated payback was about 12 years without any rebates or incentives coming in from the government. With the government rebates and incentives, we hit payback in a little over 9 years.
Great. Here's another question. Aside from using Zavala less, what energy efficient retrofits did you employ?
In all of our schools, whenever we're doing window replacements or anything like that, we're going to the high efficiency windows. We're doing, whenever we do roof replacements, we're going to high efficiency roofs with thicker insulation on them. And some of the basic philosophies that we're doing anytime we do upgrades to our schools, we're making sure that we do those. Again, we're moving away from the VCT flooring in all of our campuses to either the polished concrete flooring or LVT, the luxury vinyl tile. Again, the maintenance on the luxury vinyl tile or the rubberized floor that we used at LBJ, it's just incredible. It reduces the amount of time that it takes to dust or mop a school significantly, a lot less damage. Used to at every school, we would spend the 2 weeks before the kids got back doing nothing but stripping and scrubbing floors and re-waxing them. I have a 200-person custodial department, and that's what they did for 2 solid weeks before school. Now, in the schools where we have the LVT or the rubberized flooring, they're doing other activities. They're changing light bulbs. They're checking the flush valves on toilets. They're doing the stuff to make sure the school's ready to go, not just the floor's ready to go. Other things that we've done that we did at Lady Bird is the low volume flush valves. Whenever we replace toilets or the flush valves, we're going to low flow, controlled flow flush valves and water reduction. All of my kitchens now have gone to the cook to serve methodology. We have upgraded nearly all the kitchens in Irving ISD over the last 10 years with high efficiency freezer coolers and just better kitchen equipment in general that allows us to do the cook to serve mentality pretty much across the district.
Okay, great. That sounds like you pretty much answered this next question. Have you been able to take some of the energy efficiency technology that works best and install it in other facilities? And has this had an impact on the energy footprint of the older facilities? So is there anything?
Absolutely, yeah. The main thing there is weather stripping and windows. That, and as we're replacing older HVAC systems, we just did a chiller project on all my chiller plants last summer. We went to much more efficient chillers for the HVAC. So anytime we have the opportunity, if we're going to replace something, we're going to replace it with the most energy efficient that we can afford. Again, there's some really neat stuff out there in chiller technology right now, but it's really expensive and it's got that 18 to 20 year payback, which is basically the life of the product. Personally, guys, I have problems with that. But if I can get something that's going to give me 30 or 40% more efficiency with a 4-year payback, that's the kind of things you have to look at and that we're implementing. One of the things we have looked at was, could we put solar on on some of my other buildings just to reduce my peak load? What's killing us right now is not so much our energy usage, it's energy delivery charges from Encore. I actually pay as much in delivery charges as I do in usage charges now. The big problem with an old existing building is, number one, the roof structure was not designed to support solar panels or solar panel type infrastructure. The other thing is I have a lot of stuff on the top of my old roofs. I have exhaust fans, vent fans, HVAC units, gas lines, electrical lines. There's just so much stuff up there. It's very difficult to come up with a cost-efficient proposal with a good payback to allow us to do that. So then we started looking at maybe doing some solar parking on some of our buildings. Again, the issue is sometimes some of these buildings I've added on 4 or 5 times. So I've got 4 or 5 different feeds going into it. So by the time we put the solar up, put all the additional feeds in there and all the different switching would have to do to utilize it, I've not been able to get to that really good payback level. Now, bond money comes up and we start doing full retrofits on some of these campuses. That's a total different. Then you have the opportunity with a bond program. If you're doing a total retrofit, then you're already cutting out concrete. You're already redoing electrical systems. That gives you an opportunity to go in there and really do some of the top of the line upgrades. But one of the things that we're starting to do in all of our campuses is LED lighting upgrades. We started with our competition gyms with LED lights. We're moving to our parking lot lights. And then within the next 2 to 3 years, we'll pretty much have everything but specialty lighting, all of your troffers, all of your classroom, all of your office lighting replaced with LED lighting. That's an incredible cost savings.
Great. Another question here. Do higher insulated windows and walls necessitate more air filtration and energy use in the air system?
Actually, there's specifications on how much outdoor air we have to bring in the actual HVAC system. We actually used a transfer type system at Lady Bird Johnson that brings outside air in, mixes it, filters it, mixes it with existing air within the building, and then actually uses that to actually supply the building. So we're basically pre-cooling the air as it comes in, and we're double filtering. So you got the filtering from the outside air coming in, then we've got our regular filters that are in the actual air conditioning units. So we've actually had less dust, less contaminants, less of all of that actually inside the building just from the type of technology we used. The thicker windows and the thicker walls actually reduce the influx of contaminants from the outside. I can tell you that in any of my buildings, our indoor air quality is much better than what's in the outside air. And in Lady Bird, it's even better than my standard regular buildings.
Great. Was Lady Bird able to take advantage of the operating savings and use it towards something else?
Yeah, we actually, we took some of the savings, especially the operational savings. We actually have learning modules that exist inside Lady Bird. We bring, can't remember if it's 4th graders or 5th graders. We bring every 4th grader or 5th grader in there, and they go through these learning modules where they learn about solar panel, they learn about geothermal, they learn about wind, they learn about water. We developed that program basically off of the savings of Lady Bird. We put that back into instruction.
Great. Which technologies would you consider the most exportable to existing and new builds?
Existing builds, your most exportable technologies for upgrades are going to be your geothermal. That can be retrofitted into a building fairly easily if you have enough land mass and land space. If you don't have enough land space for geothermal, you're going to have to go with high efficiency chillers or something else like that, because geothermal does take a large lot. And the other thing is basically windows and envelope. Whenever you replace windows, when you replace roofs on building envelope, it's very inexpensive to add additional insulation or add better windows when you're doing those things. For new buildings, if you can't afford the solar right now, please at least make the building solar ready. And what I mean by that is you've already got the switch gears in there. You've already got the centralized electrical closets, electrical panels all in one area, so that when you do want to add solar, you've got one central place and you're solar ready, you're ready to go. You've built the roof with the structure underneath it to support the solar panels. So, new buildings, I'd make sure that I do everything I could. The thicker walls, the newer windows, the better roof, gray water harvesting, I do everything that you can, because again, it's not that expensive. Your real expenses on your solar. And if you can't afford the solar now, just make sure that when you build the building, you make it solar ready.
All right. What is the average age of the school buildings, and is asbestos a concern in older campuses?
The average age of my school buildings is about 48.9 years, 48.8 years across the district. I have very limited asbestos concerns in my district. We did an asbestos survey a little over 10 years ago where we went through the entire district and basically did an analysis. So we know where there's encapsulated asbestos, where it is and what campuses, and actually where it's located. Also, whenever we get into any of the mechanical, electrical, or plumbing, for example, in a chiller plant, we check again to make sure we didn't miss some asbestos insulation when we did our initial survey, and we document every bit of that. But again, then we recheck just in case.
Okay. How much did the geothermal system cost?
That one I don't remember. I will have to find that and get that one back to you.
All right, thank you. Here's another one. Have you reduced kitchen waste and plastics?
Absolutely. We actually use recyclable materials. When we first started the school up, we actually had a pulper, so that all of the leftover food, the plates themselves, even the knives, the plastic knife, forks, and spoon, and they still are, they're all made of either plant-based or corn-based materials. Even our plastics are made with corn-based to make them recyclable. So everything, the food waste and everything would go into the pulper. Unfortunately, about 4 years into the program, all the companies that used recycled waste like that only wanted pre-consumer waste so they could make animal feed out of it. They would no longer accept ours because I could not give them a 100% guarantee that there wasn't any type of meat product in there. So the only thing you can do with post-consumer recycled material is to make mulch. So what we've done since then is, for about 5 years, we actually brought the material out to the service center, and we had one of the largest mulch stations in the state of Texas. We're actually using that mulch for the actual mulch that we use within the district. But recently, even that's gotten fairly expensive. So what we do is we recycle that material. It all goes into the recycling bins, but we still use the plant-based plates and all the corn-based plastics themselves.
Thank you. Was the capital cost only through bond money, or did you have to apply for grants?
We actually did this with bond money. We had a very supportive school board at the time that saw the future, and they saw the cost savings of what we were doing, and saw that, long term, and saw the long-term savings. So we were able to again do this with the capital cost with our existing bond money from our 2007 bond. But it was nice to apply to Encore and get the rebates on the energy production and the energy efficiencies. We did discuss doing some things with grants, but we did not have to do that.
All right. Does the Irving ISD contract for any renewable energy from their energy service provider?
Right now, we're using Direct Energy, which I believe has an 18% renewable energy content. But when we go to the actual provider, we try to look at what they're actually doing, but we don't specify in our actual contracts a minimum percentage. But that is part of our evaluation criteria when we're evaluating an energy provider. Okay.
For the LED lights, are you retrofitting old fixtures such as for direct wire T8 LED tubes, or putting in entirely new fixtures, or perhaps using plug and play where you don't have to change anything? How did you make the decision which route to go?
On all the gym lighting that we've done, we've actually replaced the fixtures directly. The designed as LED fixtures are more efficient. And again, we're looking at a high bay fixture where you actually want to go in there, replace it once, and not have to do any repairs. As far as our indoor troffers go inside the building itself, we are currently evaluating the difference between a plug and play fixture and a true LED fixture. We've seen the costs of the LED fixtures come down significantly. So we're looking right now, it may be as easy to replace the troffer, the entire troffer, and at about the same cost as trying to go in and replace just the bulbs with the plug and play. Just because the difference in the labor. An electrician can go in there, cut the two wires to the troffer, place the troffer, wire the two back up, and be in and out in about 15 minutes on a replacement. Where sometimes if you have to replace tombstones or do some of the other things like that, it will actually take more time to just replace the bulbs than it will the entire fixture. So we're doing that analysis right now.
Okay. From a financing perspective, can you speak to federal ITC credits availability and use? Are new builds eligible for such tax benefits?
Normally, a school district does not have access to those federal tax benefits because we're not a tax-paying entity. Some of your providers may be able to access that, but you're going to have to work with your individual provider on that, your actual installer, and see if they can get any of those tax credits. But again, school districts normally are not eligible for that because we're not a taxable entity.
Okay. Has the school system looked at using a commercial energy broker to manage electricity supply contracting or energy savings performance contracting, ESPC, for upgrades?
We actually use a commercial energy broker to help us when we go out to do our contracts. They help us write our bid specifications, help us go out to bid, et cetera. And they also help us monitor the market. And we keep them on contract 12 months a year to help us monitor what's going on continuously with energy pricing and energy savings opportunities. We have not used the ESCOs in Irving ISD. We've been very fortunate. Our board and our financial stability has always allowed us that if I can put together the package to justify it to the board's been able to find the funds that we need to do the upgrades.
Okay. Is LEED certification necessary or required for going net zero or solar ready?
Absolutely not. LEED is great certification, especially when you're doing something like we did 10 years ago, where you're on the very, very front edge of something. But you don't have to do LEED. LEED encompasses a lot of things that you don't have to do to get all of your savings. Many things are great about LEED, like as much locally sourced material as you can, but it does cost money to get the certification. If you're still doing your solar, you're still doing your building envelope, you're doing the things you need to do, the LEED certification is not necessary. It's nice to do. If you qualify, I'd recommend you spend the $10 or $15 or $20,000 to go ahead and put it on the building, because it impresses people when they walk up.
Yeah. Okay. I have a question. Do you want to say a little bit more about the students and how they have how they engage? I know you said a little bit about how they engaged with tracking the energy and water use, but I know you have ambassadors. Can you just talk a little bit more about the students and how they are interacting with and learning from the school?
Absolutely. We actually have two different programs. One I talked about, where the fourth graders, the fifth graders come out and learn. It's a tour where the kids actually come out and learn about the school and learn about what's going on. Again, I apologize, I can't remember if it's fourth or fifth grade. Some go, I think it's the fourth grade that goes to Lady Bird, and fifth grade goes to our outdoor learning center. But again, they spend a day in Lady Bird learning about those technologies, even at the elementary level. At the actual school itself, we have a group of eighth graders called ambassadors. They're the ones that know the building. They're taught basically how the building operates and how everything goes on. And they actually perform most of our tours for us. They will actually take you out and they'll show you, where the rainwater harvesting tank is. And they'll show you they'll show you the wind turbines. But it's actually the kids themselves that are engaged in helping us talk about the technologies. And they're also, again, they're still engaged to this day, even though, it was at the very beginning they helped me tune the school. They still monitor this stuff. When they see lights that are left on, when they see things that aren't working right, they let their teachers know to put work orders in. So the students are actively engaged every day in the school and the concept of the school, which is pretty awesome. One of the other things we did with Lady Bird that I forgot to mention earlier is on our lighting controls. We were one of the first schools to use a vacancy control, not an occupancy. So since we do daylight harvesting, you walk into a room, the lights don't turn on automatically. You only turn the lights on if you don't have enough light. But once you leave the room, they'll turn off after a set time after everyone leaves the room. So you actually have to engage to turn the lights on, but it's automatic to turn them down, to turn them off. And the kids love that. When that doesn't work, that's when I start getting work orders. Because they'll let the teacher know that the lights aren't working. They turned on when we walked in today. So the kids are just massively engaged in the concepts and in the entire school.
That's great. So another question, does Irving ISD use electric buses?
No, we do not.
Okay, not yet.
This is-
All all right, another question here. Uh, is there an energy information kiosk for students and visitors at Lady Bird Middle School? Is this shared with the rest of the school district?
Yes, we actually have 2 green screen kiosks, and we're just now in the process of upgrading those right now. We started that process before COVID. Where basically it has a virtual tour of Lady Bird. It's got current power generation. It's got current power consumption. It's got all the information we just talked about right there on that green screen kiosk. Again, we started upgrading those to a new generation of technology and computer technology right before the pandemic hit. So I believe we have those running now in the school again. We do not have that back on our website yet. Once we get that communication link reestablished, which I'm hoping will be over this summer, all that information will be available on the Lady Bird Johnson website.
Great, great. So that will be available for anyone, anyone that you have to be with a secret password and part of the district. That's great.
And we do have some internal data that we use in our math classes and social study classes and things like that. It's a much deeper level of data.
Okay.
And not allow outside access to. But that's one of the things that we're working right now is making sure we've got the correct firewalls and everything. So the data we do have is the only data that's allowed out.
Okay. All right. Well, I think that's all the questions we have here. Anyone have more questions they would like answered? We still have 5 more minutes. Or Jim, if you want to say something that hasn't been asked yet, a little further.
Not that I can think of. It's just, the school's been a pleasure. We were kind of scared of the geothermal systems. We'd never done water source geothermal before. But we're 10 years into it. And I think I've done 3 repairs on anything in the geothermal system in 10 years. And 2 of that was pumps on units. And then I had 1 small leak that took us less than a day to find. It's just been, the building's been a pleasure, from the maintenance and facilities side. It's just been pretty phenomenal.
Yeah, that's great. Well, I do understand that the building is used a lot for activities and so forth. I'm guessing because of the energy efficiency and so forth.
Absolutely.
So I remember in the tour you talked a little bit about some of the multi-purpose rooms, and I know that having a smaller footprint that makes sense and multi-purpose rooms are a part of that. Would you care to just mention a little bit about some of your multi-purpose rooms and how that has helped?
Yeah, absolutely. Our library can also be reconfigured. All of our bookshelves are on wheels. So our library can be completely reconfigured into a very large conference or meeting room. It's got its own projector, it's got its own setups, the whole 9 yards. So the library is not just a library, it's also a meeting room or conference room. When we did the fine arts area, the building's basically split down the center. You have all of your academics on one side, you have all your noisy stuff on the other side. All right. When we're doing testing, that makes it much easier to segregate things for testing and run, if we need to, after hours, run just those areas for testing. When we have special fine arts or athletic facilities, we just run those. But even within the fine arts, instead of the band hall, the orchestra hall, the choir room, all having separate and individual practice rooms, we combine those. So if there's 4, I think it's 3 or 4 practice rooms that they all share, and they have a sign-up system that's set up between the directors of those fine arts programs to utilize those actual practice rooms. Unfortunately, you go into most of your middle schools and you'll find 1 practice room in the band hall that's actually being used for the practice room, and the other 3 are full of junk. So what we did was make sure that the rooms that were available are continuously being used as practice rooms.
Makes sense. One other just quick thing. I remember noticing in the tour that you were showing some of the equipment that's often outside. It was inside and people could view it and learn about it and so forth. But I believe you said it turned out to be a lot more efficient. You want to comment on how that worked out?
We actually have the inverters. We actually put the inverters inside the school instead of outside the school. As you know, solar panel comes out direct current, DC. kind of like the current that runs in your car, the 12-volt DC that's in your car. But to run a building, you got to have 120 volt, 277, 480 volt AC, alternating current. So that's what the PV powered inverters do, is they convert that DC from the solar into the AC that we can utilize actually in the school. Normally you put those things outside where they're rained on and they get hot and everything else. We actually have noticed it kind of hurt our head. We had to put about 4.5 tons of air conditioning to keep those things cool, and the rest of the area. But they're also running significantly more efficiently since they're not outside in the heat and the elements. And it's looking like the lifespan, you normally have about an 18 to 20 year lifespan on an inverter. Working with PV powered, they're looking at, they're monitoring our machines, and they're not seeing the normal degradation in the efficiency of the conversion of the DC to AC that they normally see with the inverters being outside. So they're actually thinking that we may get 25 to 30 years life out of those by having them inside. And we did it for demonstration purposes, but we're seeing an additional efficiency because of it.
All right, I got one more final question in. Looks like we're through with our time, but if you're willing to answer this, the final question. How many portable classrooms does Irving ISD have, and how are they affecting energy load?
I'll tell you right up, I hate portable classrooms. I absolutely abhor. They're not secure. They're not energy efficient. They're prone to get pests in them. They're hard to maintain. Portable solutions are just that. They should be a temporary portable solution until you can come up with a permanent solution. When I first came into Irving ISD in 2002, we had about 60 portables in the district. We are down to less than 20 active portables in the district right now. And I believe only 10 of those are actually hosting students. The other ones are actually used for storage right now. We are working very hard to remove the portables from our district just because of all the issues that are associated with portables. All
right. Well, thank you so much, Jim. And thank you, James and Michael, for putting this together. And it was great. And really appreciate everyone's time, all of those of you who showed up as well. So thank you. And we will continue.
Thanks, guys. Let me know what I do to help you.
All right. Thanks a lot.
Thank you, Jim. And thank you, everyone, for attending. And like I put in the chat, this is recorded. It'll be on the NTREG website. It'll be with the Climate Reality DFW chapter's website, and it'll be available. Jim will give it to you, and you can provide it as part of your website information as well. So thank you again. We look forward to doing more of these. So cheers.
Thanks, guys. Have a great weekend.
You too.
Same to everyone.